This is section 2 in chapter 13, which is introduction about, or talking about contingency analysis. Okay, the first part, 313.1, we talked about what? We talked about goodness of fit tests. Goodness of fit tests, these are important to determine whether population is following certain distribution or no. This is very important idea, by the way. We covered only one example. We'll be focusing on that one. Why we care about contingency analysis? Maybe situations, we care about situation involving multiple population proportions, not just 2 or 3, 4 or 5 proportions. Mutual fund company example offers 6 different mutual funds. So we need to study this. A president of the company may wish to determine if the proportion of customers who select each mutual fund is related to the 4 sales regions in which the customers reside. Another example. A hospital administrator who collects service satisfaction data from patients may be interested to determine whether there is a significant difference in patient rating by hospital department or no. So all of these involve categorical data, qualitative data. Right? That's why we have to use something called contingency analysis. That helps the decision makers to make decisions when we have multiple proportions. And the level of the data for the contingency analysis has to be nominal or ordinal. Nominal or ordinal. Categorical data. And the values determined are the counting, the frequency of occurring in each category. Number of males, number of females, number of smokers, non-smokers, number of patient, non-patient. So we have patient, non-patient. These are categorical, nominal. Married, divorced, single. Married, divorced, single, widow. These are categorical, but we need to look at the count of these. How many married? How many are married? How many are, these divorced? How many are single, etc. Okay? So it's a table. Classify sample observations according to 2 or more identifiable characteristic. And we call it sometimes a cross-tab table. And this is the formula that we are going to use, but again, we are going to use Minitab for this one. Degree of freedom, it's important to know. It's number of rows minus 1 times number of columns minus 1, okay? We still have the expected and the observed and the expected. We subtract them, we square, we divide by the expected, and so on to get the chi-squared value. Example, rural intro services provides internet access to customers in outlying areas in Midwest states. Recently, the marketing director mailed the survey to 850 customers. 221 responded. The survey instrument contained 30 questions, okay, and they were coded into 137 separate variables. Among many things of interest in this study, the marketing manager wishes to know, this is the question now, whether the head of the household employment status and education level are related. The contingency table, by the way, we call it the test for the independence, testing for independence. The chi-square contingency or the contingency analysis, we call it the test for independence. And now the manager would like to know whether the head of the household's employment status and education are related. The null hypothesis is always we are looking for things we see things they are independent. This is number 1. So the null hypothesis, again, we see things as they are independent of each other's. They don't have they are not related, okay? So the null hypothesis is the default situation. Employment status is independent of degree status. However, the alternative hypothesis is what? The employment status is not independent. So the null hypothesis is the default situation that, yes, everything is independent, but the alternative, no, they are not independent of degree status. So he wishes to know whether these are related, 2 variables are related or no. So that's what did he do? We have 2 variables, employment status, and these employment status take categorical values. Employed, not employed. Also, he took the other variable, which is the degree status, and it has categorical values. Degree, no degree. Has a degree. The person has a degree, the person doesn't have a degree, right? And after that, when we took a sample, we counted these from the survey. We counted how many employed and have a degree, how many employed do not have a degree, and so on. Right? And the question is to study or to test the hypothesis at the significance level at alpha equals 0.05. Okay? The issue is we need to know whether there is a relation between the responses to these 2 variables or no. Okay? So what we're going to do, we're going to use the chi-squared again, the same formula, but I will not do this. I will go to Minitab. Before going to Minitab, let me copy this. This is a different question, but let me take the employed. This is the employment. This is the degree status, degree, no degree. This is employed, not employed. Okay. So the number here is 141. Okay, here we go. So we're going to copy these, and I'm going to do this here. Okay, here we go. After that, what we're going to go to table, stats, then table. By the way, how many columns do we have? How many rows do we have? To get the degree of freedom now, right? Which is 2 by 2. We have 2 by 2, 2 columns, 2 rows. So it's 2 minus 1, 1, 2 minus 1, 1, multiply 1 by 1 is 1. So degree of freedom is just 1, okay? So we're going to go to stat, table, and we are going to do the chi-square test for association. We have two-way table. The columns containing the table, so we have to add all of the columns that contains the table, the data, which is employed, not employed. Let me just show it to you here. So we have employed, not employed. We have the data here, so I'm going to push these two. And labels for the table, columns with row labels. Column with row label is just this one, column with row labels. So we have the first one, which is degree status. I'm going to push it here. Then statistics, I will change nothing here. Then I'm going to say okay. Then we got the contingency table. These are the values, the observed. Look at the observed. And these are underneath them, these are the expected values, okay? As we did before, but these are the expected value. These are the totals. These are the totals. The total doesn't change. If you add these two or these two, you get the same number, right? And after that, what you have to do is look at the chi-square test value, the test value. It's clear that, okay, when we look at the Pearson, we don't look at the likelihood ratio. Forget about this one. It's just out of the scope of this class. So the Pearson, we look at the first, stuff here. Degree of freedom is 1, as we said, it is 1. The p-value is 0. So immediately we reject the null hypothesis. That means rejecting the null hypothesis tells you what? Tells you about the null hypothesis. Because the null hypothesis says the employment status is independent of the degree of state. We reject this fact. We reject that fact and accept that they are not independent. The degree and employment status, they are not independent, right? So maybe we can conclude that the employee or the employed customers are more likely to not have college degrees, right? The employed customers are more likely to not have college degrees if you look at the figure from here. Employed, it's wrongly spelled, by the way. Yeah, so they are not independent. So it's clear that. And degree of freedom is 1. Chi-square test value is 67.176. And the question is how to find the chi-square critical. We go to calculations, we go to probability distribution inverse, then 95%, then degree of freedom is just 1 single value chi-square equals. So we got 3.8, which is, again, is the critical, which is smaller than. Let's look at here. It's small. This is the degree of freedom. This is the critical value, but our value we got was 76, I think, which is somewhere here. This is the chi-square test. The p-value is 0, nothing. The p-value less than alpha. That's why we reject the null hypotheses, right? Yeah, and the funny thing, again, if you look at the table, because they are not independent, or is it? Because they are not independent, look at the employed people. We have 14, look, we have 14 have degrees. We have 141, they don't have degrees. So yeah, so these are related. They are not, they are not independent, they are dependent. So it seems that, yeah, the employed customers, let's say, they tend to have, or they tend not to have college degree. But this is another example using the contingency table.